Okay, imagine this. We're in peninsular India, right? Godavari Basin. And there's this kind of charred archive hidden in the rocks.
Yeah, holding secrets of Earth's ancient fires, like from millions and millions of years ago. It's pretty wild stuff.
Totally wild. And today we're digging into how scientists are actually reading this archive, what it tells us about, ancient climate, carbon, things that are actually really relevant now.
Absolutely. And this isn't just guesswork. We're talking about research from the Birbal Sahni Institute of Paleosciences, or PSP.
Right, they're part of the Department of Science and Technology.
Exactly. And their findings, based on these Godavari Basin samples, were published in ACS Omega. So that's our source material for this deep dive.
So our mission today, figure out how they studied these ancient fires and what the big takeaways are for understanding Earth's history. Ready to jump in?
Let's do it. First off, the timescale we're talking about is just vast.
Yeah, how far back are we going?
Well, the study looks at palaeofires all the way from the late Silurian, that's like 440 million years ago, up to the Quaternary period, which is the most recent 2.58 million years.
Yeah.
But their main focus, that was really the Permian period, so around 250 million years back.
Okay, Permian, a quarter of a billion years ago. So
Right.
how did anyone even first suspect there were massive fires back then? What were the first clues?
Well, the earliest hints came from finding visible bits of charcoal, macroscopic charcoal, in these Permian coal fields. Randiganj coalfield in India is a key example.
Ah, okay. Coal and charcoal. Makes sense.
Yeah, it suggested these, widespread fires happened in the ancient swampy forests, probably tied to seasonal droughts.
But wait, how did they know the charcoal wasn't just washed in from somewhere else? Like evidence transported over distance?
Exactly. That was the big question. Was it burned there or did it travel? It's like, finding ash in your garden. Did it come from your barbecue or the neighbor's bonfire?
Good analogy. So this newer Godavari Basin research tackled that specific problem.
Precisely. They looked closely at shale samples this time, not just coal. And they used a technique called palaeofires analysis.
Paleo what now?
Palaeofires analysis. Think of it like microscopically sorting all the tiny bits of organic stuff preserved in the rock.
Okay, sorting microscopic plant debris. What kinds of stuff did they sort out?
They identified a few key types. There's trom, that's just your general background, plant bits, pollen, tiny fragments.
Right.
Then PaleLCH, that's the crucial one, paleofire-induced charcoal, stuff definitely formed by fire.
Okay, PalACH is the fire signal.
And then there's OXCH, which is oxidized charcoal. That might have been altered after the fire, maybe moved around, exposed to air or water for longer.
So different states of burntness or preservation. How did they actually tell the story from these different charcoal types? Did they need more than just sorting?
Oh yeah, much more. This is where the really advanced techniques came in. Raman spectroscopy, rock evil pyrolysis, FTIR spectroscopy.
Sounds complex, high-tech stuff.
Definitely. These methods basically analyze the chemical signature, the fingerprint, of the charcoal itself.
And that lets them tell what?
It allowed them, crucially, to distinguish between charcoal that was formed right there, in situ, and charcoal that got transported in from elsewhere, ex situ. This is a really big step forward in this field.
Ah, so they could tell if the fire was local or not? That's huge.
Yeah.
So what did this reveal about the Permian period in the Godavari Basin?
One of the most interesting findings was how the layering of the rocks, the stratigraphy, tied into the charcoal story. It was all linked to sea levels back then.
Sea levels, how does that connect to fire evidence?
Well, during times when the sea level was lower, they called these regressive phases. The evidence for local in situ fires was much clearer, better preserved.
Okay, low sea level, clear fire signal. Makes sense.
But when the sea levels rose, the transgressive phases, things got messy. The charcoal they found was more mixed, more oxidized, more of that OXCH stuff.
So rising seas sort of jumbled up the evidence?
Kind of washed over the area, yeah. It indicates these really dynamic environmental shifts happening during the Permian. The coastline was moving back and forth, and that affected how the fire evidence got locked into the rock record.
That's fascinating. It's not just about fire, but the whole geological dance. What's the big picture implication here? Why does studying 250-million-year-old fires matter today?
Well, it ties directly into modern climate change discussions. Understanding how all that organic matter, that carbon, was buried and stored after these massive ancient fires gives us insights into long-term carbon storage in the Earth's crust.
Ah, so like natural carbon sequestration.
Exactly. If we want to develop effective carbon capture and storage strategies now, understanding how Earth did it naturally over geological time is incredibly valuable. These ancient processes can inform our modern efforts.
So lessons from the deep past for our future climate.
Absolutely. And beyond that, this research just gives geologists better tools, a more refined way to read the rock record. It helps them interpret past ecosystems, how vegetation changed over time, the frequency and intensity of fires. It sharpens the picture of the past. This improves paleoclimate reconstructions and can even help fine-tune geological dating.
So this deep dive into the Godavari's charred archive really does unlock some vital secrets about Earth's history, especially its fire history and carbon cycle.
It really does. And it leaves us with a pretty provocative thought, doesn't it?
Which is?
Well, thinking about these huge natural fire events from the deep past, how might learning about them change how we think about managing wildfires today, especially with our climate changing so rapidly?
That's a really important question to ponder. Good point.
And something for everyone to think about.
Definitely. And for those of you listening who are preparing for the UPSC exams, this is really relevant stuff. Think about the implications for environmental history, the interplay between geology and climate. These are core concepts, for mains and maybe even prelims.
Good point. Understanding these long-term Earth system processes is key.
Right. So if you found this deep dive useful, please do like, subscribe, and maybe drop a comment if you have more questions. And just to reiterate, our discussion today was based on information released by PIB, the Press Information Bureau, Government of India, a solid source for your prep.
Thanks for tuning in.
Yeah, thanks for joining us on this deep dive.